Ifsar is a radar technique that uses stereo pairs of radar images and photogrammetric processing to derive the Earth's surface. A digital elevation model represents the elevation of Earth's surface, including features such as vegetation and buildings. A digital terrain model provides a bare Earth representation of terrain or surface topography. Both are highly useful datasets for visualizing our planet for scientific and commercial landscape study. The advantage of radar technologies is that it is an active system and generates its own source of illumination in the form of radar pulses when imaging the terrain. Ifsar can map through the smoke of a forest fire, through rain clouds, and can also be flown at night. Therefore, Ifsar is an efficient process for capturing large geographies. Detailed elevation models are used for a wide variety of scientific and commercial purposes. Hydrology or watershed modeling is one of the premier applications, as the greater the elevation accuracy, the better the hydrology model. Hydrology models also help determine flood extent and assess potential flood damage. Elevation data is critical for creating 2D relief maps, 3D fly-throughs, and physical raised relief models. Here is a brief demonstration of Ifsar elevation data in Global Mapper and ArcGIS. Load the Ifsar file into Global Mapper. We can create contours in Global Mapper using Ifsar data. Go to Terrain Analysis on the top menu bar and click on Generate Contours. On the dialog box, you can designate contour interval and other criteria. You can also view the DTM with contours in 3D with the 3D viewer. Click the 3D viewer icon on the top menu bar. The 3D viewer window will open after several seconds. Using the mouse or arrow keys, you can rotate and move the 3D model to view it from different angles. You can also exaggerate the Z values or elevation values by clicking on the green colored icon with the up arrow to increase the exaggeration, or click on the green colored icon with the down arrow to decrease the exaggeration. By clicking on the blue colored icon on the menu bar, you can simulate water elevation, which is a quick and easy method to simulate flooding. The two icons to the right of the blue icon with the up and down arrows are used to raise and lower the water elevation. Click on the icon farthest to the right. The icon with the gear symbol will open a dialog box where a specific water elevation can be entered. It is also very easy to generate a profile in Global Mapper using Ifsar data. Click on Tools, Path, Profile, LOS. Click on the start point of the profile, then right-click at the end of the profile. A graph showing path, profile, line of sight will appear. Line of sight and basic cut and fill calculations can also be performed. Viewsheds can also be calculated using Ifsar data in Global Mapper. Click on Tools, Viewshed, then click on the map to place a tower. Global Mapper uses a transmitter tower in its viewshed analysis, but it can be used to represent some other structure. Once the tower is placed, a dialog box opens where criteria used in the analysis can be entered. Click OK, and the viewshed is calculated. To use Ifsar data in ArcGIS 10.1, you will need to change the file extension from .bil to .flt. Next, open Arc Toolbox, Conversion Tools, Do Raster, Float to Raster. This will convert the Ifsar data from floating point to grid format. After the conversion completes, the grid file will be loaded into ArcMap. Double-click on the GRD raster to check its properties. Check the No Data and Spatial Reference. If these are blank, remove the raster from ArcMap and open its properties in ArcCatalog. Change the no data value to -99.99. And spatial reference to WGS 84. Add or drag the file into ArcMap. To view in ArcScene, the file will need to be reprojected from its native geographic coordinate system to a projected coordinate system. Open Toolbox, Data Management Tools, Projections and Transformations, Raster, Project Raster. A dialog box opens. Select the Ifsar dataset. Select the output raster. If saving to a folder, keep in mind to keep the file name to 13 characters or less. Select a projected coordinate system. When the reprojection completes, the raster will be added to ArcMap. Now we can create a tin from the raster. Go to Arc Toolbox, 3D Analyst, Conversion, from Raster, Raster to tin. Dialog box opens where the user selects the input raster, the output tin, and Z factor. It may be best if the Z factor is set to 1. When the tin is created, the Z factor can be changed in the tin properties. Once the tin is successfully generated, the tin will display in ArcMap. Make a note of where the tin is saved. Close ArcMap and open ArcScene with a blank document. In ArcScene, add or drag the tin file into the data frame. The tin should appear with a default symbolization. Using the mouse, you can rotate and move the 3D model to view it from different angles. To change the Z value or exaggeration, double-click on the tin to open its properties. Then click on the Source tab. The Z-unit conversion factor can be changed here. If the color map will not display, a workaround is after changing the Z value. Remove the tin, then add the tin. The color map should display at the new Z value. If you want to drape a photo on the tin, add a georeferenced photo to ArcScene. Open its properties and click on the Base Heights tab. Select Floating on a Custom Surface under Elevation from Surfaces at the top of the dialog box. Select the tin and click OK. The photo should now be draped on the tin surface.